Hey everybody, we're back and this is video number 4 and we're going to talk about your radio systems today. So I've got a lot of information here that I'm going to try to condense into about a 20-minute video, and I'm hoping to get these down to like 10 minutes, but there's just so much information I gotta share. So when you think about your radio that you're putting into your airplane, you need to think about the type of airplane you're flying. If you're flying a park flyer, that's totally different than flying like one of the 197-inch wingspan planes that I fly. When I think of the different radio setups, I used to have a half-scale Pitts, and in it I had 2 FM receivers, each had 2 batteries, and then I had kind of a power distribution box, and this was 15 years ago, old technology, but I had some redundancy there. Then I had the MSL-1. That airplane had 2 receivers, and they were, well, actually it started on FM with 2 FM receivers, but then I changed it to the 2.4, and I had 2 receivers on that, each with 2 batteries. The MSL-1, I only have 1 receiver, but I have 2 batteries hooked to it. So it depends on the type of airplane you have. You know, I have many people ask me, you know, they've seen me say that I run out of channels. I fly an 18-channel radio, and I'll explain to you how you can run out of channels pretty quick. So let's say that you have 2 independent elevators, and each of those need 2 servos. In theory, that could be 4 channels right there. Each of your ailerons could have 2 servos on a big airplane. So right there's 2 servos. So really quickly, you're up to using up 6 of your channels. If you had 2 servos on the rudder, you could, in theory, use 2 channels. And the reason you like to use 2 channels is you can use the sub-trims to make sure none of those servos are binding. You can still do it mechanically, it just takes a lot more time. Now me, because I use so many channels, I usually, if I'm gonna have 2 servos on an aileron, I'll try to trim those mechanically and not use channels. But if I'm not gonna use up anywhere near my 18 channels, then yeah, I'll probably do that, because that way I can trim everything from the radio. So it's really easy. Let me use the GB, it's a little bit easier. This is a basic, you know, what I kind of call a 4-axis airplane. So you've got roll, pitch, yaw, and thrust, okay? Easily, on a giant scale airplane, could use 2 servos for each elevator like I mentioned. So you got 2, 4, 6, 8, 10 servos or 10 channels. And if this is all I'm gonna do, I'm gonna set that airplane up as a 10-channel radio. As a 10-channel airplane. So when we then start thinking about all the different things we might have in an airplane, you need to think about your wing setup. You know, on my airplane, I can set the, on my radio, I can set up that I have individual ailerons, I have individual flaps, I could have speed brakes or spoilers, I can have individual elevators, I can actually have a V-tail configuration. I can have a flying wing configuration. You can have your flaps, your retracts, the brakes on the wheels. You could have speed brakes on the side of the fuselage. You can do so much with auxiliary channels. So now what I want to do is talk a little bit about the setup. And when I talk about the setup, the reason I wanted to do this video is I have sat at many fly-ins or sitting at the flying field and see somebody crash. They look at their radio and say, my radio just went dead, or it had a mind of its own. With all respect to everybody, some of these so-called radio problems are you stalling your airplane. I had a person say to me one time, well, you can't stall an airplane going fast. It's called an accelerated stall. And yes, you can stall an airplane the moment you get the angle of attack to a point where the wing quits flying. So if you want to take an airplane really fast and yank it up as hard as you can put the plane into an accelerated stall. You could be turning around really, really quick, doing low circles, and pull that elevator up too much where your angle of attack gets so high that that wing stalls, and all of a sudden the plane snaps and crashes, and people say, my radio just did that. You accelerated stall the airplane. If you've got somebody who flies full scale airplane with you, have them take you up They need to know what they're doing, of course, but you can pretty easily do an accelerated stall in a full-scale airplane by just going into about a 50-degree bank, and you just start pulling back on the stick pretty quick. Now, make sure you know what you're doing. Don't pull the wings off the airplane. You want to be within the flight envelope where you won't pull off your wings, okay? But as you pull back on that stick, you know, going 90, 100 knots, you can hear the stall horn come on, and that's an accelerated stall. So I think a lot of your crashes fall into two different columns when it comes to radio failure. One is you're accelerating, stalling the airplane, or you're stalling the airplane, or you're crashing the airplane, or you're flying an airplane that you've crashed that receiver a whole lot and it's just decided to take a dump. Now there's other reasons, and I'll get into that in a minute. So let's talk about your radio setup. You need to think about how many RXs do you want. In the old days, we would put multiple RXs in airplanes. Nowadays, our receivers has 2 antennas, so there's kind of like 2 receivers in there. If you got redundant battery or you got a power box or something to make sure you've got more than 1 battery on it, you're probably going to be okay. I never use the BEC coming off my electronic speed controller, except on my very small airplanes, because that speed controller takes a dump. I've just lost my receiver. You need to think about your RX placement, where you're going to put that receiver. Okay, I've seen some studies where carbon fiber will block your signals. You don't want to have a carbon fiber firewall. Put your receiver antennas right up against that. You need to also think about not placing it really close to other electronics like your ignition system on a gas engine. Now I know we don't end up with as much frequency problems with FM being, getting the noise into FM that we used to back in the old days. You could have a metal to metal connection vibrating in an FM radio, an airplane that had an FM radio, and actually get enough noise that it would cause your airplane to crash. We don't have that. Then you need to think of your number of servos. How many servos do you really need in the airplane? You know, my big transport's going to have 42 servos. You know, I've flown planes routinely that had like 16 servos. You need to think about what you're doing there. The longer the wire, the more the signal will drop going out to that servo. So if you put 4 servos at the end of a 15-foot wire, chances are they're not going to work. I did experimenting. You can go back and find the old videos somewhere on my YouTube, where I started experimenting with a single servo. I think it was at 14 feet. I added another servo and it got twitchy, so then I brought it back to 12 feet, added another servo, and I think I was running 3 servos with 10 feet of wire okay. But that's the reason the power boxes came out. That's the reason S-Bus came out with Futaba. S-Bus is basically a network signal that you can put the wire virtually as long as you want. Well, that's not accurate, but it can be longer than your airplane would ever be. The power box systems give you individual servos on wires, and you have like channel 1 will have like 5 outputs. Channel 2 could have 5 outputs. So those power boxes are awesome. You need to think of how many channels do I need for my airplane. Okay, if you got an 18-channel radio, normally you can make it work with anything. I wish I had a 32-channel radio, but I can't afford it. You need to think about your batteries. Okay, if you've got a small airplane, and I always used to joke, if your airplane's over 500 bucks, I put 2 batteries in it. If it's under 500 bucks, you might not worry that much. And I mean that as a relative term, because I know some people fly $200 airplanes and that's all they can afford to do, and if that's your only airplane, you love it, you might put 2 batteries in it. And I'm talking about the receiver batteries. I use voltage regulators on my giant scale airplanes because I usually run 12 volts for the battery power, but drop it down to 6.4 volts. Now, there's controversy out there, and I've gotten in some arguments with people. I know 4.8 volts is what the minimum is that your receiver needs. There are a lot of receivers made now that will hold, I think, 7.4 volts. But when I put 7.4 volts to some of my high-end servos, they'll twitch a little bit looking for center. If I run them at 6.4 volts, they're absolutely rock solid, no twitching, no nothing. So it might just also depend that I'm mixing a bunch of different servos too. So now I'm going to talk about system failures in radios, what I really think it is. And this is the system failing, not you having dumb thumbs, not you accelerating, stalling your airplane, not you crashing it and blaming it on the radio. These are real radio problems. So I have seen people, when they have crashed their airplane, they take the wing off it, and I look in there and it's a rat's nest. Everything's shoved in there, wires are touching the servo arms. You know, if you've got a Z-link on that servo arm, it could really easy chafe. A servo wire, get your positive and negative touching each other, short it out, and you just lost your airplane. Or it could, cut into your signal, and all of a sudden you're shorting out your signal, your digital signal. So you really, really need to think about what's going on there. And then I just thought of something when I said digital signal. Another way you can also trim your servos is if you have digital servos and a servo programmer. So I'm going to digress for a minute. I said earlier you like to use one channel per servo, like on an aileron. If you got two servos on the aileron, you want to have one channel for each so that you can trim those from your radio. If you got digital servos out there, you can trim them from the digital programmer. So now back to the show. So poor setups, loose plugs. I make all my own servo wire. Okay, I bought one of those Hanson Hobby kits. I build all my own servo wire, so I know exactly how they're made. I saw an airplane crash one time, and as we was going through the wreckage, I noticed a bunch of the servo wire connectors had bare, you could see the copper wire where the plastic insulator had moved back, and if anything would have fallen across there, it could have been a metal chip, a metal flake, anything, it would have shorted it out. Ultimately, we found out what happened was the battery plug had pulled out of the receiver a little bit. So he had a switch, and it pulled out of the receiver, and he lost power, and it crashed. Another thing is bad switches. I only use commercial grade toggle switches. They're 24 volt switches that I buy from DigiKey or wherever for my receiver switches. The hobby switches, I know there's some really good ones made out there, okay? But I had one fail on me one time on a test rig, and it blew my mind. So if you watch some of my past videos, I like to test different ESC and motor setups, and I had a switch on there to turn on and off a receiver. One day it wouldn't work, and I got it out and took my fluke meter to it and found out that the switch had gone bad. And I thought, well, hell, if that went bad on an airplane, I'd crashed my airplane. So I don't use the standard plugs that come with the radio. I'm sorry, the switches that come with the radio. And then there's poor battery management, okay? I'm lucky because my radio has telemetry to tell me what my receiver pack battery is. So in my ear, I've set an alarm. If I get below 4.9 volts on my receiver pack, I hear it. It says 4.9 volts. Actually, it says warning, 4.9 volts. And that is to tell me my receiver pack has gotten low. But something's got to be really wrong with my system because I've got 12 volts going into a regulator. If I hear that in my ear, I've run my 12 volt batteries down to nothing, okay? But I would say many of the plane crashes I've seen is where people went out and flew all day and they kept putting gas or kept charging the batteries, but they never thought about recharging their receiver packs. So the receiver battery packs. So think about this. I've got servos that have telemetry on them, and I bought them just to understand what kind of amperage load I was hearing. And I don't know if I remember right, but it's something like 4.8 amps or something like that is what one of my 650 ounce servos could pull. So I set an alarm in my in my radio, that if I ever heard 4.5 or 4.6 volts, it would just tell me, just so I knew how much it was pulling. And on my elevator coming out of a loop, I got the warning on my MSL2. So your servos can pull an enormous amount of current if you've got big, 600 ounce. Well, it doesn't really matter because it matters with how big your milliamp volume is in your receiver battery. So if you've got a little bitty like 800 or 1000 milliamp battery and you fly all day with 6 or 8 servos jerking around, you can run that pack down pretty quick. So always, after every flight, stick a meter in and see what your flight pack voltage is. You might have a servo going bad. You might have one bound up in there and it's just constantly pulling the current down. Okay, I had a friend had a separate servo on his tail wheel. And the reason he did that is because one time his tail wheel he thought the shimmy of his tail wheel was what was destroying the gear on his rudder servo and making his rudder quit working. So he had a separate servo on his tail wheel. Well, one day when he couldn't turn it very good, and I was looking at it, and I said, I don't think your tail wheel's working right. And when we opened it up and plugged the radio in, you could hear that servo on the tail wheel just grinding away. And who knows what current that thing was pulling the entire time he was flying. The entire time he's flying, that servo was locked up. So always check your battery. And then the last thing I want to touch upon is the people who crash all the time and take that receiver and put it back in the airplane and crash again. Take that receiver and put it in the airplane and crash again. Then they build a big top flight P-51 or Corsair or whatever, take that same piece of garbage servo that they've crashed 30 times and put it in an expensive airplane. Then their radio takes a dump and they blame it all on Jetty, Futaba, Spectrum, whoever the flavor of the day is. All that radio is a piece of crap and I'm never buying it again. If you crash your receiver, you really should send it back to the manufacturer to be checked out. Now, I know there's a lot of Chinese junk receivers you can buy for virtually nothing and put it in an airplane, like a park flyer or a little foamy, and fly it. If you're okay with that, great. But if you're taking a investment of a motor, a airframe, maybe retracts, maybe an electronic speed control, maybe an electric motor, you can real quick get to $500 in a motor and a speed controller alone. You throw an airframe in there, you get into the $750 to $900 range real quick, and then you're going to take some junk, and I shouldn't say Chinese because I think all of our stuff comes from China, but I mean the junk stuff. You know, most of my receivers cost between $100 and $200. So I've seen receivers people can buy for $19. I wouldn't take one of my big airplanes and fly it on a $19 receiver. So I hope this helps everybody. My next video is going to be covering how you actually set your aircraft up to fly successfully. And I know I'm going to piss a lot of people off, okay? Because I'm going to attack all you people that fly nose heavy airplanes and tell you why that is not the best way to be a pilot. But I'm going to talk about your throws, your exponentials, your CG. I'm going to talk about the ground handling. I'm going to talk about everything to set an airplane up to make it fly really cool. And I know some of you haters are out there are going to go, well, what makes you an expert at this, Damon? Well, you know, I'm not an expert. I hate the word expert. I've just done this for many, many years. I've flown since 1987 without a receiver failing and crashing my airplane. I don't know the last time I've crashed an airplane, except for like a little park flyer trying to fly between power lines. I think the last technical crash I had would have been my Pitts biplane, my half scale. I was up in the air doing an inverted spin, sucked some air bubbles, lost the engine, had to land it out about 200 yards, and I landed hard and broke an axle on the wheel, and it did a donut. Didn't hurt the airframe, bent the gear a little bit, but I think that's the last time I've had a crash landing. Knock on wood. So look, everybody, thanks for all the great comments, and keep watching my videos. And if you want to share them, share them. If you want to like them, and if you want to subscribe, subscribe, and have an awesome day. Rock on. Be safe, everybody.